Leslie.
So this is what gives you the 500,000 volts, the dome. The dome cost me $15 40 years ago.
So if you had this one going and that one going,
and you put it closer than 4 feet, you'll get a spark between.
Oh, that's cool. That's cool.
So you know.
Yeah, naturally these
weather conditions.
Naturally, these electrical engineers will know a lot about it.
This is the beam tube of my thing where I made hydrogen. The top's broke. I had a controlled leak in here that went in and fed it into my proton gun, and it flew down here. And along the way, I had allowed that up there. There's a oil diffusion pump that I built in high school to drive this thing from a high floor pressure because all I had was refrigerator compressors going backwards.
So you got this one. Excuse me.
Now, so as the beam comes down here, it collides with air, and it's 10 minus 6 millimeters, it would make ions, and the ions would go back in the same beam.
But you're not using these for it, are you?
This is the voltage supply. I had a little thing in here that picked up the voltage here.
Oh, they cracked it.
Used it to feed to ionize the hydrogen.
Right, ionize.
Right. These are corona electrodes that pick up the voltage gradient in here.
So you did use
each one of these has a field around them, and the fields from these point toward the middle. So they come around. They're like circular, and there's a point in the middle. So what happens is they're going in, and as they're accelerating, they get squeezed in, and when they're coming out, they get squeezed out. But they're going faster when they get squeezed out. So they don't, it doesn't pull them out. So it ends up collimating the whole thing. The problem is it collimating the same beams that the protons were. And so what I did is I split these things, which warps the field. So I get two centers here. I get a positive and a negative center, so the electron, and it spirals down now. And so the electrons or the protons go down this way, and the ions go back the other way in a different beam. They kind of go around each other. One's going this way, but
so
they avoid each other. And I can put a getter substance on the end here and pick it, catch them. This is and at this end of the beam, it splits them into hydrogen ions and protons and hydrogen ions and
So you split the
oxygen ions.
You split the hydrogen ion.
Hydrogen ion, hydrogen without the electrons.
Hydrogen,
it's a proton.
right. It's just
I
one
take
proton.
The proton and I take the hydrogen.
Strip the electron
I
right
strip
off.
the electron off with a high voltage field inside.
Right.
It's a very sharp point.
You strip the electron right off.
And then
all you got is a proton.
It shoots it down the thing.
So you got a proton accelerator.
And I put a lithium film in here.
And it takes a picture of it.
Foil rather, and it splits lithium. It makes helium. And when I catch helium showing up on the thing,
on the film.
And then, helium.
All right, so that's what they were used for.
So this one the otot way. Let me show you this and get this one off.
That's the.
And this can be polished with any number of polishing compounds or something, or maybe very fine emery or something to get the corrosion off. I don't know the corrosion really makes a lot of difference, except it acts as an insulator and probably holds more charge.
So
this one here, I got down here and I discovered that I turned it on and nothing happened, and I discovered the police had ripped the wires out of here and cut it back there, so that I think they were taking it as evidence for a drug manufacturer or something, or maybe the guy wanted one on his house. I don't know. But this is it's each individually built and they're different. Okay. So this one, I think I had to put it, but I don't even remember if it had a capacitor or not. Starter capacitor.
So
I
reconnected the motor.
Yeah, and so you can have. I'll cut it put it back there somewhere. You can take it. Right. It's just wired in now. But this is. How is this here the polyethylene is on the top, and the steel and the aluminum is on the bottom.
So it's reversed.
So it pushes the things off. Right. Catches these.
But
things.
now, will this?
And there are two combs.
If this was running alone,
and
if this was running alone,
it would make it
negatively charged. Like this, could I pick it up?
Yeah. Well, it's kind of. You get in about here and you get zap, okay. On the thing, but you get out here, it's not attracted to your finger.
The other one you can.
Too far away for it to actually find your finger. Yeah.
This is negative. That was a positive.
Well, both of them do that. It's just that the feel that
it's less of a
it's
field
shooting
here.
out in all directions, and if it happens, you happen to be close enough to it,
Right.
and
You're
it's
gonna
not
get
shooting
that.
out that way,
Right.
then you know.
But
then you get,
but that one will go further out.
that one, they're the same thing.
Same distance.
This is that's a positive one. This is a negative one.
Right.
The positive one goes out and fans. It will go out and hit something and bam, it fanned into a brush. This one comes out of the air as a bolt and fans onto the dome.
Okay.
And that's the difference between positive and negative. That's why lightning branches from cloud to ground, because it's positive, coming down.
Okay. Okay.
And it doesn't, So.
All right. So these are two of the ones.
Let me
These are